Hello folks, we come to the part 3 video of this exercise 5.1 and we are taking up this problem number 5 where they give us a function. It's kind of a breakup function. The domain is distributed into two parts. For every x which is less than or equal to 1, the function is defined as x. And for every x or that part of domain which is after 1, it is defined as 5, constant function. And this is the identity function. So this is how the thing is. They ask us to check the continuity at x equal to 0, at x equal to 1 and x equal to 2. Let's check. So first at x equal to 0, let's check how to do it. What do we have to do? Because at x equal to 0, it is purely lying in this. When it is lying in both the areas, like when both the definitions is applicable, it's better to check the left limit and right limit. But when it is exclusively lying in one, we can take the simple definition and we can prove. So we'll have to show that limit as x tends to 1 f of x is f of 1. This is what it should show. So consider limit as x tends to 1 f of x. So that is limit as x tends to 1 means at 0. It is at 0. So at 0 means it is in this part. So function is defined as x. So that means as x tends to 0, it is 0. And f of 0, because when we look at the domain, it is lying here, that is also 0. So therefore limit as x tends to 0, f of x is f of 0. Therefore f is continuous at x equal to 0. That's there. Now second is at x equal to 1. Now this, as I said, because at 1 there is this function getting distributed left side, there is a different value, right side it's a different value. So it's better to check the left and right limit. So how we are going to check this is to show that limit as x tends to 1 minus, that means on the left side of 1, and we will check the limit as x tends to 1 right side of 1 is equal to f of 1. We'll check this. So for that, let's consider limit as x tends to 1 minus f of x means left side of 1. So it's very clear to us actually. If you can look at the domain, 1 here, this part is 1 minus, this part is 1 plus. Here the function is defined as x and here the function is defined as 5. So limit as x tends to 1 on this side, we have analyzed the function is defined as x is tending to 1, so this will become 1. Then we'll check limit as x tends to 1 plus. 1 plus means it is going on the other side of 1 where it is defined as 5. So on the left side it is defined as 1, but on the right side it is defined as 5. So they are not same, so it is not continuous there, right? When they are not same, they will not be continuous. So therefore you can write limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Therefore f is not continuous at x equal to 1. That's about that. It's not continuous. Then we'll take the third subpart. In the third subpart, it is at x equal to 2, which is exclusively this part. So again, it's enough if you take the normal definition to show that limit as x tends to 2 f of x is f of 2. Consider limit as x tends to 2 f of x, that is f of x in this area is 5, so it's 5, and f of 2 because it's that area is 5. So limit as x tends to 2 f of x is f of 5. Therefore f is continuous at x equal to 5. That's about it. Now so that's all. These three parts that they have asked us, we have done that. So we'll continue with this, and in this question number 6 there are many subparts, I think. No, question number 6 they are asking us to find the points of discontinuity, where it is discontinuous. That will generally whenever we are given functions like this, place where there is a breakup happening, and the function is defined in two ways. Where x is less than or equal to 2, there is a different definition. For x greater than 2, it's a different definition. So generally a place where the domain is getting broken up, there there are chances of discontinuity. So first we check that place, then we will check the other places. So let's right away go at x equal to 2. Let's check what happens at x equal to 2. To check what all? Limit as x tends to 2 minus f of x we will check. Then we will find limit as x tends to 2 plus f of x, and we will also find f of 2. That way we will check whether it is continuous or not. So consider limit as x tends to 2 minus f of x. That is limit as x tends to 2 minus, this also we will make that little drawing. This is 2, this is 2 minus, this is 2 plus, and here it is defined as 2x plus 3, and here it is defined as 2x minus 3. So in this area it is defined as 2x plus 3. So x tending to 2, very close to 2. So 2 into 2 plus 3. So 4 plus 3, 7. And limit as x tends to 2 plus f of x. So that is limit as x tends to 2 on this side, 2x minus 3. So it is 2 into 2 minus 3, 4 minus 3, 1, not same. Yeah, so discontinuous. Limit as x tends to 2 minus f of x is not equal to limit as x tends to 2 plus f of x. Therefore, f is discontinuous at x equal to 2. Now, other places where in other places of the real number line it will be continuous. Why? Because if you see everywhere on this side it is defined as 2x plus 3, it's a polynomial function. So there it will be continuous. On this side everywhere it is defined as 2x minus 3, that's also a polynomial function. So there it will be continuous. So the only trouble giving point was at x equal to 2, and there we have checked that it is discontinuous. So that's about it. We can take the 7th problem and see what it says. 7th problem says that you have f of x as f of x is modulus of x plus 3 in cases where x is less than or equal to minus 3, and it is minus 2x in case where it is between minus 3 and 3, and it is 6x plus 2 when it is greater than or equal to 3. Okay, so this is the domain. If you want, we can understand the domain like this: minus 3, 3. X is less than minus 3. Function of x is modulus of x plus 3. Between this, it is minus 2x. Here, it is 6x plus 2. So that's how the function is defined. We will have to check points of discontinuity here also, here also. So let's do it. At x equal to minus 3. What happens? To check limit as x tends to minus 3 from the minus side f of x, limit as x tends to minus 3 from the plus side f of x, and f of minus 3. So limit as x tends to minus 3 from the left side is this definition: limit as x tends to minus 3 modulus of x plus 3. Right? So basically it's modulus of minus 3. Modulus of minus 3 is 3, you know. So 3 plus 3 is going to be 6. And limit as x tends to minus 3 from the plus side. That means on this side. We know it is minus 2x. X tends to minus 3 is minus 2x. So minus 2 into minus 3 is plus 6. And f at minus 3 is the same as this definition. So that is also going to be 6. So all these three things are equal except for it's continuous. Limit as x tends to minus 3 from minus side f of x is equal to limit as x tends to minus 3 from plus side f of x is f of minus 3. So f is continuous at x equal to minus 3. Then at x equal to 3, what happens? Let's consider limit as x tends to 3 from the minus side f of x. That means on this side it is going to be minus 2x. So minus 2 into 3 minus 6. Then and limit as x tends to 3 from the plus side. That means on the right side. Limit as x tends to 3, it is 6x plus 2. So let's substitute. 6 into 3, it's 6 into 3 plus 2. So that is 18 plus 2, 20. See, there is a problem. Therefore, limit as x tends to 3 from the negative side f of x is not equal to limit as x tends to 3 from the positive side f of x. Therefore, f is not or discontinuous, because that's the word that they use, is discontinuous at x equal to 3. So that's about it, and that's how we finish this video. With more problems we can come in the next video. Thank you.